Good morning, all. Today we are going to see the topic about design and analysis of algorithm, and which is nothing but in this topic we are going to see that particular topic, which is nothing but n queens problem. Before to enter the topic, we have to know what is n queens problem, what is that problem, how can we solve that problem in algorithmic approach. So the objective of the n queens problem is replace the n queens in n of n, which means either it is 2 by 2 matrix or 3 by 3 matrix or 4 by 4 matrix. The kind of in either kind of matrix there is no two queens, which means we have in that matrix we can keep some same elements in that matrix, either 2 or 3 or 4. That same elements could not be attack each other, which means that the elements which is already defined, the same elements is called queens. So no two queens attacks each other. This means no two queens can be in the same row, column or diagonal. We already know if we define any kind of 2 by 2 or 4 by 4 matrix, there could be some rows and columns. There are two diagonal faces out there. So in that case, there is the same elements, which means queens. No two queens can be present in same row or same column or in diagonal, which means this is the n queens problem. So what is the input of this problem is an integer n representing the size of the chessboard, which means number of queens, and the number of queens means chessboard. We already seen about the chessboard, which is nothing but equal n of n matrix. We have to take that size of chessboard is the input value, that is n number of integers, and the number of queens means we can already defined same number of elements which is presented in that matrix. So this is the input, and what is the output means all possible configurations of the board where n queens are placed without attacking each other. It's nothing but we already discussed that thing. So in that case, what is the output means the same elements, which means the queens, two queens which should not be present in same row, column or diagonal. This is the output of this n queen problem. So we'll move to the algorithm of the n queens problem, which means print one solution. How can it give the solution? We have to define the solution. So we have to define nq, which means n means number of elements, which means n of n, which means 2 by 2, 4 by 2, either 4 by 4, either 2 by 2 matrix or 4 by 4 matrix, 6 by 6 matrix, whatever it is. Which is n, and q is the number of queens. Number of queens is nothing but the same elements which is already predefined in that given matrix. So columns are also set diagonal 1 and diagonal 2. We already discussed about the diagonal 1 and diagonal 2. Each and every matrix there could be two diagonal faces in that matrix, that is diagonal 1 and 2. So board is equal to 1 into minus 1 of n. In that case, what is minus 1 into n means we have to compare each and every elements in that matrix up to n. We have to backtrack that matrix values up to minus 1. This is the minus 1 into n. We have to make the backtracking operation here, because if we want to compare the two elements means that could be satisfied, means we have to move the next element with the move the next element to compare with the previous element. So we have, in that case, we must do the backtracking operation. So here define backtracking. That backtracking operation we have to define the element define that backtracking operation is or. So if or is double equal to n means we can move to the main main problem of that particular algorithm. So it is written board.copy. For C in range of n, what is C means? C is columns. In that case, if R is nothing but the number of elements which is presented in that matrix, which is equal to n. If C is column means what is diagonal 1 is or minus 2, which is number of elements presented in the columns minus presented in the matrix minus columns, which is diagonal 1. R plus C is diagonal 2. We have already discussed about the diagonal 2, right? What is diagonal 2? It is the another diagonal of that given matrix. There should be two diagonal faces. This is the another diagonal faces in that matrix. So what is diagonal 2 is R plus 1. Diagonal 1 is R minus 1. Diagonal 2 is R plus 1. If the range is under these conditions, if the range is present under this condition, we should make the move for the next step, that is continue. So columns dot add of C is C, diagonal 1 dot add. We have to add. What is dot add means? Make a move for the if we define the column in that given matrix is 4 means we have to make the operations, which means comparison operations in column 1 is done means we have to move the next column. When we move to the next column, we have to add the before comparison column. So columns dot add of C, diagonal 1 dot add of, we already defined what is the diagonal 1 means R minus 2, R minus C. What is diagonal 2 means R plus C. So diagonal 1 dot add of R minus C, diagonal 2 dot add of R plus C. So both of R is equal to C. Solution of backtracking is, we can move the next step of the next element of that backtracking solution, that is R plus 1. So if we find that comparison is satisfied, we can return the solution. If it doesn't satisfy that condition, which means the two same elements are present in that column or diagonal 2 means we have to remove that particular kind of element. So columns dot remove of C, diagonal 1 dot remove of R minus C, diagonal 2 dot remove of R plus C. So the return value is none because we couldn't satisfy that condition, so the return value is none. So backtracking operation could not be happen. This is the main operation of this n-queens problem.